Let me tell you one thing that helped me understand programming, especially loops like while and for. That is the go-to statement. I know what you're thinking. If you've heard about the go-to statement, you've probably heard it's old and unreliable and nobody uses it and nobody likes it. But hear me out because I'm gonna explain it. So when I first started programming back in high school, I can't really say I had that much trouble understanding programming, but I had some trouble understanding scopes, using curly braces, and making sense of the for loop. Overall, making sense of how the whole code works, the line of execution of code. For me, I never really grasped it. But when I discovered the go-to statement, everything just made so much sense. I understood the way the code executes. I understood that when you get to the go-to tag statement, the code literally, the reader, the compiler, the program literally goes to that place and continues execution on. And then you can have another go-to and jump from here to there. And yes, allegedly this is messy, and in production code you're not gonna use go-to because it's hard to work with. You're much better off using functions. But what helped me understand the thread of execution, the way the code executes, is go-to. So you might want to give that a try. If you're a beginner programmer and you're not exactly sure, you're not exactly grasping the way the code gets executed, the order of stuff, might want to give go-to a chance. Try programming with go-to a little bit and see where that takes you. Also, let me go on and say that all of this is my personal opinion, but I'm just gonna try to give to you a new way to look at programming, especially if you're quite new to this domain. I'm gonna give you a new perspective on two various programming ideas. Speaking of functions, the number 2 things on this list is functions always returning something. Now, I've tried teaching complete beginners, and one thing I noticed so many people have trouble understanding is functions that don't return anything. Functions that just do something. And that's because most people, when they think about functions, they remember what math told them about functions, right? You have f of x, and that function, you know, takes a value, and then it returns a value. So like f of x equals x times 2 plus 1. Whenever you say f of x, it's gonna replace that with 2x plus 1. But when you get into even basic examples with functions that don't return anything, I notice people get confused by this because, hey, it's a function. Why? You just call a function, you don't use that value. What's up with that? Let me tell you something, it's absolutely okay if you make functions that always return something. But now it really depends on your background. Do you have a math background? If you do have a math background, I recommend sticking to functions that always return something. It might help you understand the way the code works. If you don't have a background in math and you have no idea what a function is, I do recommend sticking to functions that do not return something, functions that just execute some piece of code. Because in essence, functions that return something just replace your function of parameter with the final value, and functions that do something, also called procedures, just execute whatever is inside that function block. Whatever you said you wanted to happen when you call that function is just gonna happen. Going through the code, jumping to the function, executing the code and going back, returning. Also, remember to use lots of functions and drink water to stay hydrated. Yeah, the third thing I noticed, so many people have problems with, even university students studying programming or computer science, is the concept of divide and conquer. The reason I notice many people have trouble with this is because they've never been explained exactly what it is and how it works and how you are supposed to solve a computer science, a programming problem. Obviously, if you're familiar with programming, you've heard everyone online talks about divide and conquer. That's how programmers solve problems. And the way you solve a problem is you split it into smaller problems. And if those small problems are still you cannot solve one of them, you take that one problem, that small sub-problem, and you divide it further into more sub-problems. That way you get to really elemental things, like sub-problems that can get solved in one line, and start with that. what is one thing you can solve about your problem, one calculation? Can you think about it? And trust me, once you start dividing the problem into subproblems and solving those subproblems, it's a lot of the time it's also gonna solve other subproblems in the problem by themselves, and it's a really cool phenomenon. Also, try not to think about it in programming terms. Try to think about it in logical terms. Let's say you need to make a program that changes the contents of a file and adds a question mark at the end of each line. For a beginner programmer, this might sound like a daunting thing, but when you actually get into it and see what the subproblems of these problems, it gets a lot easier. Let's take it like that, right? What could be the subproblems of this problem? Well, you need to know how to read a file. You need to know how to split that file's content into lines. You need to modify each of those lines. You need to put back those lines into one text, and you need to write a file and override the file. Let's start with reading a file. What are the subproblems of reading a file, right? You need to understand to see what the function for reading a file is, how your programming language works with files. And depending on your programming language, reading a file might be several lines of code. Well, what you can do is you can write your own function, read my file, and when you call that function, all it does is it returns the inside text of that file. Now, this way you have to write several lines of code once, and when you want to do that, to solve that subproblem, to call that subproblem in your actual problem, you only need to call the function you wrote. And you can do this with every subproblem. You can have for every subproblem in your problem, you can write a function for it. And that's gonna make things so much easier, trust me. Now, of course, there are ways and ways to solve problems. For this example, you could maybe just read the file line by line. Well, maybe you don't need to split the text. Maybe you don't even need to actually read the contents and just append to every line. See what goes. See for your specific problem how you can solve this. And very importantly, don't concern yourself with performance at first. If your problem does not specify it needs to be solved with a certain performance, don't concern yourself about performance. Do it the way it makes the most sense, because that's how it's really going to be in real life situations. Sometimes you maybe want to sacrifice some performance for better code readability, for better code structure. That is exactly my fourth tip on this list. Don't concern yourself with performance unless you absolutely need to. So here's the thing, many programmers, even in university, everywhere actually, they concern themselves too much with performance. They think that their code needs to be fast, it needs to be executed fast, but the trick about this is that in our day and time, it's 2020, 2021, 2022, I don't know what year. Computers are super fast. That's just it, there's no way around it. You don't have to write super fast programs for those programs to actually run super fast. Now, I've encountered real life problems with this, and even in my work and in my own projects, where I thought some piece of code is gonna be terribly slow because it processes tens of thousands of files or of documents, and you know, I ran that piece of code and it was like so damn fast. Like, how does it even work that fast? So absolutely no, don't concern yourself with performance. Don't make unless the program absolutely needs to be performant. That's what the problem is, or you actually have performance problems, like it actually runs too slow. Do concern yourself with code structure and organization, because if your code is messy and unorganized, you're not even gonna be able to optimize that thing later to make it faster. So keep that in mind. If you're liking this video, please do hit the like button, it really helps me a lot. And if you like my content, I would absolutely appreciate it so much if you subscribed. And if you want to talk to me, you can find me on Facebook and Twitter, which I have linked down in the description. Let's talk, I'm always there. Ask me anything. That being said, I have been Dave. Have a great weekend.